All right, so now we're doing car loans. I'm assuming that you're going to be dealing with car loans before you start dealing with your IRAs and annuities, but I may be wrong. But for cars, you've got installment loans. Installment loans are loans that you pay off with weekly or monthly payments. Your fixed installment loans are regular monthly payments. So sometimes you're going to see fixed interest rates versus variable interest rates. Your variable interest rates means that your payments are going to fluctuate the cost of them. Whereas if you have a fixed loan, your payment's going to be the same no matter what. So your regular payment amount, the formula is PMT equals your principal times your rate divided by in this case with car loans is going to be 12. We're going to take it out monthly on every single one of these examples. Over 1 minus 1 plus your rate divided by the number of times compounded to the, see that right there? That is a negative. Don't forget that negative. Negative n times t. Again, t is time in years. So number 1, suppose that you decide to borrow $15,000 for a new car. You can select one of the following loans, each requiring regular monthly payments. Installment loan A is a 4-year loan at 8%. Installment loan B is a 6-year loan at 10%. Find the monthly payments and total interest for loan A. So loan A, you have $15,000, a 4-year loan. We pay it monthly at an interest rate of 8%. You take that information, plug it in. Again, I'm going to walk you through calculator. If you do the calculator, do the bottom first. This divided by this, enter, plus 1, enter, raised to this, enter, 1 minus that number, enter, write that number down, do this up top, and then after you hit enter, divide that by the bottom. 'Tis a lot. Don't drop these negatives. Don't forget those. So you run that and you get $366.19 per month that you're going to be paying. So that is your monthly payment. You also have to find the interest that you're going to be paying. So to find the interest, you take your payment times 12 months times 4 years. And that gives you $17,577.12. From that number, you subtract the $15,000 that the car actually cost. And you get $2,577.12. So in the 4 years that you've had that loan, you've paid an additional $2,500 essentially. You're always going to pay more if you take a loan from the bank. It just, depending on your interest rate and the time span of your loan, depends on how much you pay back. So B, you're doing the same thing, only you're doing it for loan B. So your principal stays the same. It's still $15,000. But now we're talking about a 6-year loan. Again, we're paying it monthly, and our rate's higher. Our rate's at 10%. So plug it all in, get your answer. You get $277.89. Well, that's a lower monthly payment. That's a $90 lower monthly payment, right? Calculate your interest. So your payment times 12 months times 6 years gives you $20,008.08. Well, when you subtract the $15,000 that the car was, that means you're paying $5,008.08 in interest. So C wants you to compare monthly payments and total interest on the two loans. So you've got lower monthly payments for the 6-year loan, but more money in interest. FYI, it always goes this way. So not no matter. The longer the loan, the more money you're going to end up paying back in the long run. So it's always worth it to go with a shorter loan than it is a longer loan. So number 2, suppose that you are thinking about buying a car and have narrowed down the choices to 2 options. The new car option. The new car costs $19,000 and can be financed with a 3-year loan at 6.18%. Your used car option is a 2-year-old model of the same car that costs $11,500 and can be financed with a 3-year loan at 7.5%. So if you notice, our years are the same. What's different is the cost and the interest rate. The older the car, the highest your interest rate is going to be, by the way. So we're going to run the new car plan first. The new car was $19,000. Our interest rate was 6.1%. Our time was 3 years, and we're making monthly payments. We plug all of that information into our formula, and we get monthly payments of $579.57. Your used car was $11,500 at a 7.5% interest rate for 3 years and 12 months in a year. Plug all that in. You get a monthly payment of $357.73. It wants the difference in monthly payments. So difference in monthly payments, you take the higher, subtract the lower, and you get a difference of $221.84. If you notice, this problem did not ask you to calculate the interest. So if you're actually comparing two car options, you don't just want to compare monthly payments. You also want to compare the interest. How much interest would you pay back on this plan, and how much would you pay back on this plan? And would it be worth it? And you got to remember, this is a heck of a lot cheaper than that. So that needs to be taken into consideration too. So number 3, there we go. Suppose that you are buying a car for $60,000, including tax and license fees. You saved $10,000. Good Lord, I worry about my typos. That's supposed to be $10,000, by the way. $10,000 for a down payment. The dealer is offering you 2 incentives. So incentive A is $5,000 off the price of the car, followed by a 5-year loan at 7.34%. Incentive B, no cash rebate, but provides free financing, no interest, over 5 years. What is the difference in monthly payments between the two offers? Which incentive is the better deal? So for A, we're doing incentive A. Now, our car costs $60,000. We have $10,000 for a down payment. So that means our principal amount is actually going to be $50,000. While on incentive A, you've got $5,000 off of that. So $50,000 minus $5,000 is $45,000. So that's your principal amount. It's a 5-year loan at 7.34%. Plug that in. You get a monthly payment of $898.29. Come over here. Incentive B, where you have no cash rebate. So we're dealing with that $50,000 principal amount, 5 years. Our interest rate is a 0%. So we can't run the formula. We can't do this formula. What you're going to do instead is take your payment, take your total cost, divided by how often you're paying. So 50,000 divided by 5 years, and there's 12 months in a year, so 5 times 12 is 60. So you're taking 50,000 and dividing that by 60 and getting monthly payments of $833.33. Well, if you look at that, even though we're borrowing more money, our monthly payment is less. So our difference, take the highest minus the low, and it gives you a difference of $64.96. But here's the difference. This you're paying interest. This you have no interest. So incentive B is the better option. Moral of the story, if you can ever get 0% APR on anything in the world, it is worth it to go with that rather than an interest rate. I may be wrong, and some of your parents may be able to tell me a time where they've experienced the opposite, but anything from cars to like Lowe's does 0% APR during certain times for appliances, and when you get your own house, you're going to want to do that. Big Sandy's runs the same kind of deal, but you want to wait those places out until they offer that 0% financing, and that's when you want to go for it. And now we've got annual fuel expense. So annual fuel expense is annual miles driven divided by your miles per gallon times the price per gallon. So suppose that you will drive 36,000 miles per year. That's a lot, by the way. And gas averages $3.50 per gallon. What will you save in annual fuel expenses by owning a hybrid car averaging 40 miles per gallon rather than an SUV averaging 15 miles per gallon? So we're going to look at this. Hybrid car. We're traveling 36,000 miles in a year. It gets 40 miles per gallon and gas is $3.50. So in a year, a hybrid car guzzles down $3,150 in fuel. The SUV, your 36,000 divided by the 15 miles per gallon times $3.50. The SUV chugs $8,400 in fuel expenses. So how much money would you save by owning a hybrid? Subtract the numbers. You would save $5,250 per year by switching from an SUV to a hybrid. That's a lot of money. So B, if you deposit your monthly fuel savings at the end of each month to an annuity, hey, that was our last lesson, that pays 7.25% compounded monthly, how much will you have saved at the end of 7 years? Round all computations to the nearest dollar, which means you need to go back to your last notes where it said value of an annuity compounded n times per year. That's the formula you need for this one. But we are going back. Deposit your monthly fuel savings. So you have to take your $5,250 and divide that by 12 to get that a month. In a singular month, you'll save $437.50. Take that. That's our principal amount. Our rate was 7.25%. It's compounded monthly, and we're letting it sit for 7 years, which if you plug it all in, that is this hot mess of a formula. And when you get your answer, if you are doing that for, 7 years, you're going to have $47,691.62, which, I drive one of those SUVs, and that would be a nice chunk of change to save. It'd be really nice. But your homework is page 546, 2 through 14, and even. Let me know if you have questions.